Thank you, everyone. Are my levels okay if I speak at this volume in the back? Yes, excellent. Thank you for your patience while they cleaned up the debris from my hotel, having partially fallen apart while they were demolishing the cranes. So it's a really exciting opportunity for me to come here and talk to this group, because I think that you all, having now had a chance to go deep into the proceedings, although unfortunately not to see the talks as I had planned today, but it's clear that you're operating in a very similar space that I was operating in the early 2000s in touch and multi-touch technology, where we were in the academic realm, we had developed electronic devices, and we're building tools, and we're publishing papers, and then Jeff Hahn and Perceptive Pixel and Steve Jobs and Apple and all the others happened, and all of a sudden everything was moving out of research into industry. And it was happening in a lot of ways that were not what I expected. So for example, I did my PhD and the topic was capacitive multi-touch devices and how to use them to control different things. And I dutifully wrote my Chi and Whist papers about all of the things that we were doing, and I sort of split my time between Toronto, but I also had an internship at Mitsubishi Electric Research Labs where the Diamond Touch table was first developed, which was the first commercial capacitive multi-touch device. I wrote all of these papers, and then at the end of the paper there was this section called Design Recommendations. And what I had in my head was, when I was writing these design recommendations, was that when the time came that they were going to commercialize all this multi-touch stuff, that people in the appropriate companies would pull down the Chi proceedings, open, and just write down what we told them to do, and then ship that in their products. And I recognize now, saying that out loud, that it's a ridiculous statement to make, but I think now that I've had this chance of going from academia, where I was working on these large multi-touch devices in an academic sense, and then going off into industry at Microsoft, where first I was the architect for the Microsoft Surface Table, and then later made the architect of the E&D division for natural user interfaces. And that included things like Microsoft Connect and the Windows phones and some of the work that later went into Windows proper. And seeing how we were able to transfer some things well, but a lot of what I'm going to be showing you today are examples of things that didn't transfer well, and to tell you stories about how we might have done it better, because I think you guys are in a really exciting moment that you might be able to benefit from our mistakes. So I'm going to talk today, yes, about natural user interfaces, or the natural user interface. And this is a term that you see all the time in papers. Oftentimes the book that was mentioned a minute ago is cited as the source of the natural user interface. This is sort of, like a buzzword, like a marketing brand term, right? Like, this is not a scientific term. But we managed to co-opt this at Microsoft and use it as an education mechanism to help to improve a lot of the products that later developed. So I want to sort of tell you a little bit at the beginning about what is natural user interface and how did we co-opt this term and use it to do things for the greater good. So when I say natural user interface, people often sort of picture this, right? It's Tom Cruise doing his thing and Minority Report. We've all had our work compared to this at one point or another, right? And of course, we all know that this is based on technology that was developed at the MIT Media Lab and later became a commercial endeavor called Oblong. But of course, it looks really cool when Tom's doing it, right? And the idea is, over time, new technologies come out, right? So we see things like plug boards and punch cards are the way we control our computers, and then keyboard and mouse, and then touch and gesture, and then speech comes along, and there's this belief that there's this other axis that we'll call, naturalness. Does this feel like fingernails on a chalkboard to anyone else yet? We'll get there. There's this other axis called naturalness, and in the march of time, just by changing modalities, we somehow improve the naturalness of our technology as it goes along. And that is the notion of the natural user interface. So you ask someone, what is the natural user interface? Well, it's like an interface you'd buy at Whole Foods, right? Like it's organic. It's, some other buzzword, right? Psychologists call this the naturalistic fallacy. But I think a good question to ask is it true that input technologies in and of themselves enable something to be natural? So for example, is it really true that speech input is natural? Well, we can turn to the great wisdom that I'll show you here. Anyone recognize this before I hit play, by the way? Be really impressed. Excellent, well done. A Chatham Labs member knows it and he didn't even see a practice talk. All right, so this is a Star Trek episode in which they did a mental exercise that said, what if we had a perfect speech interface? What if we fixed the input technology? So right now, when you talk to someone who develops these speech interfaces and you say, oh, these don't work very well, they focus a lot on the speech-to-text aspect of the system. But that's not the piece that actually creates the interface. That's just getting the input signal correct, right? So Star Trek asked the question, well, what if, let's just assume for a moment that's perfect. Would that actually create a good experience? And so we can turn to that. And now, because we don't have audio, you can't hear that, right? Take my word for it.
Machine types everything It's typing everything I'm saying.
So what we're seeing on her typewriter at the moment is it's typing everything I'm saying. Stop it, stop it, stop it. Right? Because literally what it's doing is just transcribing her text. So clearly, just because we get speech-to-text right, that doesn't make the experience natural, right? Whatever natural might mean. So, let's just say, okay, so speech input, is it natural? Let's say no. So let's, I don't know, put it down there somewhere in our extremely scientific graph type thing. All right, what about gestural input? Well, let's talk about a story of hubris when I went to Microsoft. So I was at Mitsubishi Electric Research Labs. There's the Diamond Touch table. I'm sure many of you have them in your labs and have tried them before and maybe even written software for them. And, this was a big multi-touch device, and I had experience participating in the team that built the Toolkit that shipped with this, that was a Java-based thing so that you could actually write Java applications and you could use them, right? And I finished at Mitsubishi and then at Harvard, and I built a whole bunch of these things, and then I got the call from Microsoft. And I was told, hey, guess what? All that stuff you've been toiling away in obscurity in academia, we're going to make it real. And of course you recognize this because you have one of these in your living room, right? Okay. So this is the Microsoft Surface table. This is the first version of the Microsoft Surface table. And they called me up and said, help us make this thing a commercial success. So I flew across from Boston to Seattle and said, all right, I'm going to make this thing work. And for those of you who don't have a good recollection of it, here's a commercial of the thing working. And we didn't fix the sound from my laptop into the system, so if you hear a little bit of murmur, don't worry, it's not important. So here's the commercial, right? You can grab pictures and move them around and rotate them, and they follow the size of your fingers. Oh, I'll even mute, there we go. And look how happy those people are, right? So clearly this is a great thing. So, this is really neat, and Andy Wilson and Stevie Battiche, who made the first prototype, showed this to Bill Gates, said this is the future of computing, and them and a whole bunch of other people created a division. Hundreds of people were employed, big amounts of money were spent, and this was going to be the thing. And then they brought people in to try it out. And the user study says, okay, I get how to move something around, but how do I scroll it? Right? So you can move the picture, but I want to scroll, right? I want to be able to have a web browser. And I want to be able to zoom within the window. Well, not to worry, because the natural user interface can solve that problem. So they said to me, all right, hotshot PhD, solve this problem. You've been studying multi-touch gestures for years. You should be able to do this, right? And I said, no problem. So I and some other colleagues at Microsoft devised a study, and there was a published version of this work out of Microsoft Research, and we're going to do it together. You guys are going to be participants in this study, okay? And the idea is we're just going to show you a picture of the interface before we execute, and then a picture of the interface after your hypothetical gesture. And then I'm going to ask you, what gesture did you do to get from before to after? And if there is a Whole Foods natural gesture that will just sort of come from your soul, then everyone will do the same one, and I didn't really have to do anything, right? You just write down what you did. All right, so let's try it. Okay, so what are the natural gestures? Here's the before, okay? CNN.com at the bottom of the screen. Here's the after, CNN.com at the top of the screen. Okay, now don't look at your neighbors and just do a gesture. What gesture would you do to get from before to after? All right, pretty much 100% agreement. One natural gesture. Well, let's keep going. Now we're going to do this. The CNN.com window is still at the top of the screen, and now it's been scrolled a little bit. What gesture would you do to get from before to after? Right? So we're all computer scientists, engineers, other types of scientists here, designers of interactive systems. We immediately recognize the conflict, right? That the natural gesture that Whole Foods would have us do is the same gesture twice but getting different results. There's some definition of insanity that says this, right? You do the same thing twice and expect different results. So we're asking our users to be insane. Clearly that's not the right thing to do, and we can't ask our system to be insane. So what do? Well, we just don't include scrolling. And there's our hypothetical participant. Done. All right, so what did we do? Well, we invented a gesture language. And it's a pretty simple language. I'll take you through it sort of quickly so you can see how it works. And basically the idea is if you touch something with individual fingers, then it sort of behaves the way the commercial did. And if you touch it with pairs of fingers or a single pair of finger, then you'll scroll or zoom the content. Right? Anyone recognize where two-finger scrolling came from? I worked at Microsoft, so I'm not allowed to say where I got it. Let's just say there was a company in Cupertino that shipped laptops that worked this way. Okay. And of course, the Surface table worked the rest of the way too. All laptops do this now, right? But back then it was only them. All right, so whole. So just make sure we're all on the same page, right? There's our CNN.com browser window. If I grab it with one finger and slide, then it moves. Another individual finger, and I pull it apart, then it zooms. And now, with two fingers, if I grab onto it with a pair and slide, I get a scroll. Right? And if I do it with another pair, then I get a zoom. Okay? So whole and individual. Pretty simple because people had experience with this thing and it used the gestures that are built into the system already, right? So pretty good. We were happy with this gesture language. And it did match what you guys did in the room where you just grabbed the thing and moved. You just have to be careful about how many fingers you put down. Okay? No problem. Then we ran a user study. So here's an actual user study, and unfortunately because of the audio problems, you're not going to get to hear what they say, but I'll tell you what they're saying. We brought in users in pairs so that we didn't have to do the think aloud thing that people find so unnatural, and instead they just talk to each other and we'd hear what they're saying, right? And we stick the interface in front of them, and now it's an actual implemented working thing, not just the pictures that I showed before. And we said, okay, do this, right? And we'd show them a picture. We'd say, manipulate the table so that it looks like this. And we'd see if they could do it. So here are two guys working in the system. And what the first guy eventually figures out, and of course I'm sort of cutting to the good part of the study, right? What the first guy figures out is that if he mashes it with his whole hand, then it puts it into scrolling mode. And if he uses just one finger, then it's in the other mode. So this is pretty close, right? What we were aiming for was two fingers, and of course the developer who implemented the prototype just said if number of fingers greater than one, right? So then a large number of fingers works also. So if we deployed this system and he thought that's how it worked, we would still say this is okay. Right? This is a superstitious behavior he has. It's sort of like how my mom always double clicks on hyperlinks instead of just single clicking. But it doesn't really hurt anything, right? Okay. Here's another pair, a father and a daughter. They're looking to execute, and dad is sort of working in the system. And he's got the sort of interface the way he needs it to be, but now he needs to scroll, and so they're talking about it. And what he eventually figures out is that if he holds it down with two hands and then gets his daughter to come over and puts her hand on, then she can scroll. I've given this talk about 50 times, and I still get a slight PTSD response every time I see this video. So what does this tell us? Is gestural input natural? I'm going to say, no. So where does this leave us in our extremely scientific graph of all things natural? Well, I would argue that there is no such thing as naturalness. That it isn't the case that just by making something a touch system, it automatically gets easier to use if more natural equals easier. Okay, so then I say this to people, and this is controversial. So what do people say back to me? So why did I know how to use my iPhone right away? Excellent question. Really wish I had the audio for this part. That's okay. Let me see if I can. I'll unmute, and I'll point the microphone down and see if you can hear it. Does anyone remember this?
This is how you turn it on.
Can you guys hear the audio?
This is your music.
It says, this is how you turn it on. This is your music. This is your email. And there's, charming music playing. This is the web. What is this that I'm playing for you? You see this and you think it's an iPhone tutorial, right? What is it really? It's the commercial, right? They announced the iPhone on January 27th of 2007 and shipped it on June 29th. And for all those months, they ran tutorials on national television. And according to Ad Age, publicly available information, according to Ad Age, Apple spent $467 million in advertising that year, targeted largely at making sure that when you first picked up your phone, you knew how to use it. Okay. So why is my iPad easier to use than my computer? Who recognizes this program? A couple of you? It's one of the Adobe, this is Illustrator, yeah. All right, so this is Adobe Illustrator. Who has used Adobe Illustrator before? Who has not used Adobe Illustrator before? Okay. Those of you who have never used it, will you believe me if I say there are more than 800 functions built into Adobe Illustrator, okay, as of the date I wrote this? Okay? Now imagine this. Let's say I sat you down, you folks who've never used it, at a computer that had Adobe Illustrator running, and I said, don't worry, I'm going to make it a touchscreen. Would that make it easier to use? No. So why is it that the iPad version of Illustrator is easier to use? Well, as of the date that I made this slide, and it's a little bit old, this is the iPad version of Illustrator. The PC version of Illustrator had over 800 functions. The iPad version of Illustrator had 34 functions. Okay. So does this mean that Adobe is shortchanging you, that you're getting this broken experience if you use the iPad? No. What Adobe recognizes is that the context of use of the iPad is different than the context of use of the PC. We're all in this community together. This is not surprising to most of us, right? But the fact is that people sit and there's analytical data on this stuff. But typical iPad sessions where you're not watching a movie are somewhere between 5 to 10 minutes of use for a product like Illustrator, whereas for a PC it's more like 30 to 120. Right? This doesn't include all the alt tabs to Reddit, right? But I just mean the time you're working at your computer. Okay. So, why does the iPhone use a touchscreen? Well, Steve Jobs told us the answer. You go back to his keynote where he announced it, January 27, 2007. Why does it use multitouch? Because buttons and controls can't change. And they wanted to have a good web browsing device, a good email reading device, and a good video watching device eventually. And having all those buttons at the bottom got in the way when you didn't want to be doing text entry. And then, of course, they spent a whole bunch of time and energy and science and money to make the thing work okay for tapping for text entry. Okay. So, what is this natural user interface thing that everyone keeps talking about? And, is it the Whole Foods natural user interface? I'm going to say no. It's, the Robert Redford natural user interface. Who recognizes this movie, by the way? All right. So for the rest of you, Robert Redford is a baseball player. He's a really, really good baseball player, right? He's like the, what's the guy from Toronto who just signed with the Los Angeles basketball team? The Raptor who just Kawhi Leonard. He's like the Kawhi Leonard of baseball. Thank you. Okay. Anyway, whatever your favorite sport is, picture that person. Okay? So the idea is the natural user interface is the idea that you're trying to make your user feel like the natural. Okay? Where they pick it up and they just get how to use it. It's like when Michael Jordan holds a basketball. Right? And that is the purpose of Brave New World, which is the book that I co-wrote with Dennis Wixon of our work at Microsoft, although it usually gets cited as if we were talking about this thing. So, it's a good test to see if my students actually read the book as to which way they cite it. All right. A good question for all of us to ask, of course, is difficulty inherently bad? Why are we aiming for natural user interfaces? Why is this something that we need to have right out of the box? Why is the out-of-the-box experience everyone's target? Let me ask you this question. Which concert would you rather go to? Okay. So I argue that it isn't necessarily the case that by having something complex that means it's bad. But how do we achieve this thing? Well, this is the lesson that I hope that as you are doing your research in 3D user interfaces, you can start to bake into that section at the end of the paper in design recommendations when you can start to make sure that you address the issue of context. What is the context of use of the system that you're targeting? Okay? So, by hammering this over and over and over again to Chatham customers and also to people before that, we were able to achieve some good results. Now, once you design for your context and you need to build your platform, what do you need to build? Of course, sensing and representation. What is the input language you actually want people to use to give input to your system? What is the, we'll call it the affordance language, although there's another example of a term that gets misused a lot, but the user interface. And then ultimately a feedback language. So what do I mean by all of these things? Let's talk about sensing and representation. Here's another Microsoft story. Let's talk about developer experience. I, in my work, was privileged to work with brilliant engineers, computer scientists, etc., who are able to tackle a system and understand it wholly. I did not understand what commercial toolkit development really was until we at Microsoft were developing the first widespread multi-touch toolkit. Okay? Because the Surface table shipped and our toolkit shipped before the iPhone did. If you remember, when the iPhone first came out, you couldn't build apps for the App Store. There was no App Store, right? So we were the first ones out of the gate trying to help people to build multi-touch applications. Who are we targeting? Well, we're targeting people who built mouse applications because that's what they did before. And now we want them to do multi-touch. So what is multi-touch to those people? Well, to those folks, what it really boiled down to was a pair of square brackets. Why do I say it boiled down to a pair of square brackets? Because it boiled down to the callbacks that we had in our toolkit. So you recognize a callback that looks like this, right? On drag, and you get a point of P. Right? That's whatever toolkit you use for mouse input, you've got a callback that looks something like this. Maybe there's another parameter for the previous location, etc. What's the multi-touch version? Add a pair of square brackets. And now it's multi-touch, right? Holy cow, did people flip out when we did this. The feedback we got from people who had developed applications before was that they could not understand how to build applications now that there were square brackets in that callback. Why? Here's an example. Here's an on drag, right? In the old mouse world, you've got your duck, you got your mouse cursor, you drag your cursor, that sends the on drag callback into the system, and then I write a piece of code that makes the duck move. What happens in the multi-touch version? Well, what's supposed to happen is this, right? The user puts down one finger and then another finger, they drag their fingers, and then they get the on-drag callback for both the points. They process both of them, and the duck moves down to the bottom of the screen. Okay? I mean, I know this is sort of like embarrassingly easy, except every single person we brought to Redmond wrote this. Anyone know what it is already? So there's the duck. One finger goes down on the duck, another finger goes down on the duck. The user moves both their fingers. What does the duck do? That. Why did the duck do that? The duck did that, of course, because they processed just that first point there and left a point behind, right? And so they thought that our system, when they said update the location of this thing, it updated it and it went like that, right? Because they were still processing it from the old point, and then eventually it goes there. Okay. So, what's my point? My point is, developer experience is not just an interesting challenge, it is a fundamental challenge of enabling a new community, working with new technologies, to enable their technologies to be taken up in the commercial realm. And I encourage you strongly to look at this question of developer experience. And interestingly, it actually is a whole area. For those of you who don't know, I didn't know this before we had this experience and I started reading about it. It is a whole area of research, right? ACM has conferences on this stuff. Okay? But just the basic pieces, broken. Okay? Now, let's ask this question again. What is multi-touch? So, here's a story about how our best intentions at enabling people to do a lot of things backfired. Here's why. When I say what is multi-touch, we say, all right, well, you sense an object and you sense some number of points. If the number of points is greater than one, that's a multi-touch device. Ish, right? Reasonable definition of multi-touch. But in truth, some multi-touch devices can differentiate a stylus and some can't. Some can detect actual imagery and some can't. If you think back to the really exciting demos that people like Andy Wilson did in the early 2000s. He built multi-touch walls that didn't just sense when people touch, but he could hold a magazine up to the wall and it would scan it, and then it would be in the display. Right? So that's an example of imagery going into the device. Some devices can detect pressure and some can't. Some can differentiate contact, for example, from different people. So if you're working on a multi-touch surface at the same time as I am and we're both touching, it knows which touches are coming from me and which ones are coming from you. That's sort of the secret sauce of the Diamond Touch. And then, of course, we have contact data, right? So do you just have an XY point or do you have the actual geometry of the contact area? And then and whether or not it can detect hover, right, before the user actually touches the device. And if now that I'm showing this to you, right, when I first built this portion of the talk, it was when commercial devices and multi-touch didn't really exist yet, and they were just feeling out the space, and we were trying to build standards for things like the W3C, and I was jumping up and down and saying, look, not all multi-touch is created equal, right? Don't sort of tar it all with one brush. But I'm sure you now sitting there can think of individual commercial devices that had examples of these things. Right? Apple had a brief flirtation with pressure. They've now gotten rid of it in their latest phone. It lasted maybe 2 generations of the iPhone, and now it's gone. For example, Samsung experimented with hover, now it's gone, et cetera, et cetera. All right, and then of course we have all kinds of different technologies. Analog resistive, direct illumination, modern resistive, frustrated total internal reflection, projective capacitive, capacitive coupling. And if you don't recognize some of those touch technologies, don't worry about it. The point only is they're different from each other. And then each of them have fundamental capabilities as to whether or not they can do the particular function in that table. So this is the landscape as it existed in the research world in 2005, 2006, 2007. Okay? And then we say, look at all these great projects that we're doing in research and how they could change the world when you move them into your commercial systems. Now we can look back a decade later and say, what is multi-touch? Well, let's add on this column. It's roughly the min of each row, right? Give or take. Why did that happen? Again, think of your developers. If not the guys and gals writing code, think of their bosses who are defining the experience, and they say, okay, look at this iPhone. This iPhone detects pressure. You should build an application that uses pressure to do great things. It can make your drawing application better. But when you do that, you'll have invested 6 months of developer time, and only a subset of your developers will actually benefit from that feature. And the people crunching the numbers say, are you crazy? Never, 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 never. And so we get things like this, the lowest common denominator across all of the rows, and that's what defines the technology. So I look at the landscape today and say, what is spatial input? Well, we've got pretty big dispersion, right, across, I just sort of Googled and found some stuff. The bottom left, I searched for Htc Vive, and that's what came back, but it looked so cool, I decided to put it on the slide, because I want one of these. Anyway, I think that's an omnidirectional treadmill that guy is standing on. I definitely want one. But anyway, what's the point? The point is we have bare hand tracking that Oculus, Facebook has announced. At the other extreme, we have what are basically 2 Wiimotes held in your hand, right? And this is the commercial landscape as it exists today. And as I was going through the SUI proceedings and seeing, to my great excitement, the wide variety of projects that are looking at all kinds of great things, way beyond sort of basic input type projects, looking at the impacts of larger spaces and eye tracking, et cetera, et cetera. But what I really encourage you to think about is, what's going to happen when we take the min of this space? And is there a way to keep that from happening? I don't know the answer, but it's for you to try to answer the question. All right. Let's talk about input language for a second. I'm going to just give you an advertisement for something that I want you to know about that is going to be coming soon. So, as I mentioned before, we've got this book that's out of print. I bet you can't find it anymore, but it's probably in your digital library somewhere. That was the best we could do at building gestures in the late 2000s. Clearly the field has moved on from that time, right? And there's a lot more best practice that goes on. One of my former grad students who's now a professor at UCSD, he's just about to submit his Tokai paper that did the following. We looked back at all of the papers that talked about gestures in the HCI community, essentially from the advent of the user-defined gesture work that I I talked about before. And took out all the duplicates and looked to see what is the collective wisdom of all gesture design as it exists in HCI, because people keep asking us at Chatham when we're doing tech transfer projects for them, asking us in academia, how do I design a gesture language? And it turns out that there actually is a ton of new thinking. I'm sure many of you are authors on papers that are showing up in this slide, of course. And so, for example, in our sort of big survey, we eventually distilled it down to these 14 categories. And it would be a whole other talk to sort of take you through all of the categories. But discoverability, for example, this is what we call, I can walk up and figure it out without any help, right? That's sort of the user-defined gesture stuff. But my hope is that that will stop being the defining characteristic of gesture design, because it has been essentially since the user-defined gesture paper was published, and we need to move on from that as a community. What else do we have? So, for example, ergonomics. Work has actually been done to see, are gestures physically harmful to people if they do them over an extended period of time? And that knowledge is available and will be in the paper. And then also, for example, back to Joe's talk at the beginning of the conference, we speak also about recognition. So the fact that I have two gestures in the system that are too close to each other and I won't be able to recognize them and differentiate them reliably with my recognizer. Okay? So 14 factors, paper coming soon, keep an eye out for it, and it will be available. Or, of course, all of that wisdom is out there in the community. We're just summarizing it. I want to talk about affordance languages now for just a moment. And this isn't affordance in the sort of original Gibsonian, Don Norman sense exclusively. What I mean by this really is, what is the user interface that tells you how and when to do a particular input action into the system? Right? So in the PC, if you think about like the trackpad and clicking or your mouse and clicking, it's essentially a highly moded interface, right? Sometimes my mouse button saves things and sometimes it deletes things, and it just sort of depends on the state of the system. Where is the mouse cursor? So what I mean by affordance language here is, what is the UI that tells me where to put the cursor and what mode will my button be in at this moment? So let's talk about it for gestures. Who recognizes this? A couple of you? So what is it? This is graffiti, absolutely. Even more precisely, does anyone know this particular rendering of graffiti? Like this graphical layout with like it looks like this. Like, it isn't a poster, but this poster. Anyone recognize this? Huh? It was the thing that came in the box. So if you bought a Palm Pilot, and believe it or not, I was a computer salesman in the 1990s and actually sold Palm Pilots. If you bought the trick was never to hand one to the customer to try, because they'd never guess graffiti, right? So what you did was you learned graffiti and you did it, and then when they said, can I try it? You'd say, oh yeah, tell me, oh yeah, okay, sure, you can, yeah, right? Never actually let them touch it, because the walk up and use wasn't there for Palm. Anyway, backing up. This is the input language for the Palm Pilot, mid-1990s, arguably the first successful mobile touch device. And I often say it's sort of the original iPhone, except you couldn't make phone calls, it didn't have a web browser, and it didn't do email. But other than that, and it had no app store, right? Although you could install software. But other than that, it was the original iPhone. This is a sticker that came in the box, and you would, so your out-of-box instructions, could you picture, they have these unboxing videos on YouTube now? Could you picture that if they're like, you pull out this beautiful Samsung shiny phone, and the first thing you're supposed to do is put a sticker on top of it? But that's what you did, because this language was hard to learn, right? The parts up at the top that look sort of like the alphabet, right? A sort of looks like A and B sort of looks like B. But when you get down to the bottom left, and you get to things like shortcut and the stuff, in the bottom right, you see that shortcut is sort of an upward pigtail. Like there's nothing guessable about that, right? So you needed the information. So the sticker came in the box. This is an example of an affordance language that we would want to build into our systems to try to teach people or show people how to do the gestures. But, not how we're going to do it. So how do we do it? So the way that we did it at Microsoft was that because we were running the project, we're a bunch of scientists, right? We built a taxonomy. So we have all the stages of the gesture. We have the system, and as its state, you're not touching it yet, you're out of range. Then you touch the device to begin your gesture. And at that moment, you're either doing it with a single finger, or multiple fingers, or a single shape, or multiple shapes. Then you continue the gesture. Your finger actually starts to move, or your hand actually starts to move. Then, as I say, you move to stay in continuation, and then eventually you lift your hand off the device, and you go out of range, right? And this is a taxonomy of all of the different ways that we could perform a gesture in our system. So we built all of that out, used it to flatten it into this three-dimensional space, but, flattened into 2D. Filled it up with gestures, many of which were built into our system already, although some of them we didn't have any for. So, we immediately patented them and then put them into the chart. And we built a system to teach people how to use it. So the original version of this system worked in a sort of a crazy way. So when you put your finger down on the device, you'd get that guide up at the top that would show you, here's the way you should put your hand down on the device, and here's what the different shapes mean. And then as you slide your finger around, it would lead you to perform the gesture. Right? So for example, there, he put his finger down on the device, and he could perform the ant gesture with a left pigtail, or a cat gesture with a right pigtail, or he could just lift his finger up to perform ant. And of course, these names are intentionally not matching the gestures, right? So you wouldn't remember them just from the name. But there he follows cat. It says to put down another finger and slide down. So what's the point? The point is we built this gesture recognition system and this gesture teaching system, which we then applied to the multi-touch version of the gesture language that I showed you earlier in the talk. And it looks something like this. So here is our system, which we call Just-in-Time Chrome from 2008. And here it is with a single finger down on the device. And while you're panning around on the device, it sort of does the stuff that you would expect it to, because that's what, as I told you, the language was. But if you put two fingers down on the device, then you would get this widget that surrounded your fingers. And the widget that surrounded your finger, your first pair of fingers said, drag me to scroll. And then you get another widget off to the side that says, here, grab this to zoom. All right, so we're using UI to afford that, to teach that set of gestures. Okay. So what's the point? The point is, as you're building out your system, please provide this guidance for commercial tech transfer, because this was a massive obstacle in the imagination of people we were trying to get to take up our systems, because they would say, gestures are hard to learn. How can a user possibly remember to perform all of these gestures? And then we would show them a video of someone's hands on the keyboard while they're using Illustrator. And they'd say, okay, yeah, I guess we can teach people gestures, but how do we do it for multi-touch? And this is how we did it. So please, as you're building out all of the wonderful systems that you're building, think about how is the user actually going to learn to use it online and in real time. Okay? All right, the final sort of piece of our puzzle, which is the feedback language. One last story of failure. So, people would work on our device. They would touch the device and it wouldn't do what they were expecting. Here someone's pushing the play button on the play controls of our music player and it's not playing music. This is a dramatic reenactment of an experience I had sitting on the runway of an airport on an Air Canada flight. And they have, on these Air Canada flights, there are touch screens in the back of the chair in front of you. Right? And we were delayed and delayed and delayed. Every once in a while, the captain would come on and say, we're now number 15 in line for takeoff, we're now 14 in line for takeoff. But the kid who was sitting behind me didn't want to know we were 14th in line for takeoff. He wanted to keep listening to his music. But every time the captain spoke, it would come up with this little box on the screen that says PA announcement in progress, and he would try to make the music keep playing. And the play button was still visible on the screen, so we tapped it. And when it didn't work, do you think he said, oh, I guess it doesn't work? No, what did he do? Tapped it again, tapped it harder, and Newton got the apple falling on his head. I got the chair bashing into the back of my head saying, we have a feedback problem in touch. Okay? And so what we realized was so much work had been done in creating the haptic feedback you get from a mouse. And I actually spoke to the folks at Microsoft and asked them, how much money do you spend to nail the sound and the feel of a click on the button of the mouse? And I don't know that this is publicly released information. I see a camera pointing at me, so let me just say it was a lot. Greater than $0 is spent trying to nail the exact feeling of the button. Why? Because feedback matters. So we ran an experiment. We built the world's most complex prototype. We put a button on the screen and then didn't write any code. Right? So there was just a button on the screen that didn't do anything. We brought people into the room and we gave them one of two input devices, a mouse or a touch screen. With the mouse condition, they grabbed the mouse, they watched the cursor move on the screen, they put it on the button, they click the button on the mouse, and then nothing happens. And we asked them, what do you think? And they said, oh, well, the software has crashed, or it's going to do it eventually, or blah, 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 software. In the touchscreen condition, where there's a button on the screen and they tap it with their finger, and then we say, okay, nothing happened, why do you think that is? What did they say? What do you think? Do they blame the software? They say it didn't detect my touch. They blame the hardware, because the hardware is responsible for giving them that feedback that doesn't give it to them anymore. And, I laugh at this because some of the client work we do tries to look at how can we improve haptics of VR by using touchscreen phones so that you're giving input on a touchscreen because they have better haptics. And I just think how the world just, marches on. So what do we do with in our system? Well, we measured what are all the different ways that you can have errors. So we had activation action problems, we call it here. So for example, the user on the surface table, it could activate before your finger touched because this wasn't capacitive, it didn't have a ground plane, right? So things would move on the screen and people wouldn't know why. We might have accidental activation. On our Surface, it's because their arms would hit things. On my iPad, it's because my thumb always ends up on the screen while I'm trying to scroll with my other finger, and all of a sudden stuff is zooming like the duck, right? We would also find disabled content, which was like, the kid on the plane, or the example I showed you a minute ago. They're hitting play and nothing's happening, right? What is often in touch called the fat finger problem. And I'm sure many of you are familiar with this, but people do successfully physically touch the thing they want, but the system, of course, reduces that large contact area down to a single XY point to do hit testing, and that hit testing doesn't happen to be on the thing they want, right? And it has to do that reduction, or else you'd never be able to type on a small keyboard, but it causes these problems. We also get manipulation constraints. So for example here, the developer has decided that's the biggest that photo will get, but the user just keeps doing their gesture, not understanding that's the end, right? And then we also find what's called overcapture. I love this. This isn't my favorite example of it. I'll show you another one in a moment that's better. But here, this affine transformation has been limited to just allow really 2-point manipulation. And so when you put a third finger down, now you're getting sort of the wrong stuff, right? So what's the result of all this? Well, look how sad and frustrated these users are, right? And of course, this is the reason we didn't sell millions of Surface tables. And there they go, disgusted. All right, so, sorry, this is the team's moment in the sun, right? I'm gonna get it anyway. All right, so what do we do? Well, as computer scientists, what we did was we built a state transition model. But the point is, we built a feedback system that had all of these states and transitions that covered all of the different error conditions that I just identified in our system, and provided that, because now I'm working at a big company, with what turned out to be a pretty beautiful visualization system that was originally called No Touch Left Behind, and later was called the Contact Visualizer. This is still in Windows, by the way. Does anyone have a touch Windows laptop and they've seen it sort of trailing around their finger? Okay. So, there's my big contribution to Microsoft Touch. Anyway, but we take a look at the system, and, it's not just sparkles coming out of your finger, but it's a bunch of different sparkles in a bunch of different states. So, for example, we take a look at the fat finger problem. When in the original system, when you put your finger down, it would differentiate whether or not you captured onto a control, right? So the one on the right splashes out because you missed everything, and the one on the left goes in to say, yes, you got something. Okay, so that helps solve the capture problem. With the fat finger problem, we did something very subtle, and watch when the user lifts their finger. You see how it animates and it disappears at a single point? See? The point that it disappears at was the point that was used for hit testing. So when the user lifts up their finger, the last thing they see from the visualization is where the touch got sent to. For constraints, we see things like this, where the tethers would attach to the thing that is over-constrained, and it moves out to the side to say, yes, I see your finger, but no, this isn't going to get any bigger. Here's another example of overcapture where someone's left their drink on the table, and so now the system thinks that you're holding it with one finger and scrolling with the other, right? And so it's slowing down the scrolling, but now there's a trail coming out of the can to say, here's something wrong. My favorite example of overcapture is this one, where if one user grabbed a button and held it down, as you'll see in a second, then that button wouldn't work because it's in the depressed state. But now when that happens, the other user sees why, and you can let social protocols mitigate, right? That happened all the time in our user studies. You're crazy if you don't think it did. So what we see here is, the beautiful visuals I am not responsible for. What we started with was, what is the biggest, ugliest, most horrible thing? I made them in Windows Paint. And said, can the user understand these different states if we give them enough feedback? And if the answer was yes, that's fine. Then we started to make it beautiful. We made it more beautiful and subtle, more beautiful and subtle, more beautiful and subtle. And then when it stopped working, we went to yesterday's build. And that's how we landed at this sort of really subtle thing. And we still got things like these great results, that the error rates with the feedback would go down massively. And we also saw this change in perception where users would say things like, the sensors caught my actions better. And I like to see what's happening. The visuals help me to figure out what's going on. Okay? So this one is the one that I love, right? They actually thought that the sensing of the device had improved because we provided them with visual feedback of the system. Okay? All right, so now look how happy these guys are, right? Because now their table has all these great visuals. Look at them. Oh, yeah. All right. So what's my point? I will sort of take one moment to claim a little bit of spatial UI, background as I'm closing up here, just to say I have actually built. That was my buddy in grad school, who's now my colleague at U of T, Tovi Grossman, using a system we built that was a spatial volumetric display, and we used a Vicon system to track the fingers, so that you could give input to a three-dimensional space without having to wear goggles or anything. And in that system, the system could go into a rotate state, a translate state, and a scale state. And when your fingers weren't yet touching the surface of the device, it would recognize your hand posture and show you a gray version that said you're going to be in this mode when your finger comes down. Okay, so it is sort of subtle here as I hit play, but you can see that see the white version of the UI there, and then when he touches, it's turning color. Right? So some spatial cred. There it is. All right, so summing all this up, please learn from the mistakes and the pain that I spent of spending years and years and years trying to help tech transfer so much of the great wisdom from the HCI community into our corporate world and help tell this story. This is the condensed version that I got to after 3 years of being an architect at Microsoft and trying to teach all this stuff in less than 20 lessons. And it was design for context, figure out what the context is, right? What are the experiences that we're actually trying to enable? It's different if it's a living room, it's different if it's used on the go, it's different for a boardroom, different for a desk. The hardware might be different, the software might be different, et cetera. And please provide guidance for all of those folks as to how they can actually build a platform atop the system that you're building. And the sort of bonus points of this would be take a look at the other stuff in the community and start to think about how can you solve this dichotomy of breadth and depth not coming together. And then finally, remember, it's not the natural user interface, it's the natural user interface. Thank you very much for your time.
Or is there some habits we can cultivate where we can prevent
I love the question. Thank you. And there are still isolated communities in the world, right? There's one, I forget where it is, where the missionary recently tried to visit and he got killed with a bow and arrow and when he was trying to convert them. And anyway, so maybe we could get them to run user studies if we could just get them to stop shooting at us, right? I think what I have observed is, funnily enough, that it isn't a catch-22. And I am strongly of the belief that we don't know what to do with anything until we learn. And this has only been reinforced watching my babies go from, just sort of this to actually being able to do stuff. And it also comes from my background when I was doing this multi-touch work before the iPhone came out and after. Where before the iPhone came out, the first thing everyone would do when they try to walk up to a system we would put into a study is they'd tap it, and then they'd double tap it. And then if those two things didn't work, they'd walk away, or they'd say, I don't know what to do. The iPhone comes out, give people enough time to learn how to use it, they walk up, they tap, they double tap, and they pinch. And then they say, I don't know how to do it. And when you ask people about their pinch gesture, do you understand this? They'll say, no, it's a Whole Foods interface. So I believe that we have the opportunity to do good design work using, for example, the 14 parameters that you're going to see in this paper. There it is, hopefully soon. And we can design what are objectively good gestures using the wisdom of the HCI community, and then we can teach people how to use them. And I don't believe that there is this sort of inherent thing other than direct physical manipulation of grabbing stuff and moving it around. Because what everyone just did in the room when we did the first gesture was you grab it and you move it, and that's what every user-defined gesture paper, including the original one that everyone cites from Mary and Jake and Andy, says, which is you get 100% agreement on moving stuff and less than 100 on everything else. Okay. Long answer to a short question.
Another question? One of the challenges that I see with my students now with that consumer VR sort of has that standardized hardware is that they, in my pre-user interface course, I'll go through all of these wonderful techniques designed for spatial interaction, and then their first default thing when they go to actually implement something in a project is, instead of using all these techniques, I just map it onto a button and touch it because it's just on the controller and it's just like an easy solution.
Right.
It's not just the students, right? There's lots of examples of commercial products from, even like AAA game titles or ports of PC games to VR with terrible user interfaces. They're just mapping onto like the 2D touchpads and buttons and not considering sort of the new medium and designing user interface for that. And I was just wondering, based on your experiences, if you had any thoughts about how to overcome this challenge of just getting people to think outside the box of the model.
Think outside the button. Yeah. So were you guys able to hear that in the back? Yes. So how do we overcome this problem? Randy Pausch was one of the early pioneers of AR/VR, as many of you know, and probably worked with him. He named his lab Stage 3 because he talked about there always being 3 stages of media, right? Where you say a new technology comes along and it's just the hot demo. Then they take whatever's available in the world and try to make it work with that, right? And so the example he would use are like the Charlie Chaplin films that are basically you take a stage play, stick the camera, it doesn't move, and then you do the play in front of it. And then you eventually get things that are authentic to the medium, like Citizen Kane. Right? And he believed very strongly that what we need to do was to get to stage 3 for AR/VR. Right? Having now gone through this cycle where whenever there's this new technology that comes into a big company, they're spinning up and spinning up and spinning up, right? And hiring really strong people, spending tons of money. But every time we go to a client site, there's 3 new people who weren't there the last time we were there, and they're all saying things like, "Get rid of all this interface stuff. It should just be natural." Right? And we say, we have to take them on this journey from stage 1 to stage 2 to stage 3. What I was floored by when I finished my PhD was that there is an entire school, and I'm going to sound so naive, there are entire design schools who teach something called interaction design. And I thought, that's what I do. I'm an interaction designer, right? But then I went and looked at what they do, and essentially they just assemble components of existing toolkits. Right? They don't go down one level the way that we do in our community. And so, what I'm sort of hearing you say is, how do we get people to go down that one level? And I've struggled with it too with my students, where I'll say, and eventually what I just say to them is, you're not allowed to use Unity, you have to implement everything in OpenGL. Because then if you're starting over, maybe you'll get somewhere new. I think really it's about education and being able to come up with examples. And if we go back to the developer experience story that I was telling, the other thing that floored me was the dev samples that we would include. Like we had a thing in the Surface toolkit where it was, here's how you use direct sound, I think it was called. So you can actually get sound to come out and music to come out of the Surface table. And so we just grabbed a WPF application that was made for the PC, which was a piano that was rendered the wrong way for the table, right? Because it's supposed to be up on the screen, but who cares? Because it's just a sample that's meant to be, here's how you get sound to come out. So who cares what the graphics are? But then there are 100 YouTube videos of people trying to play the piano on the Surface. So my point only is, people need these tent poles to sort of push them in the different directions. And my team, where I was the architect, did our best we could, but did a bad job because we couldn't get the resources to help people to understand that the developer samples are actually all the experience samples, because people don't know what else to do except for what you show them. So the best thing that I've been able to come up with is force my students to use OpenGL, and then also take the best examples and sort of carry them forward and actually give them the code and try to force them to sort of find the space in the middle. But man, is it painful and hard. So thank you for letting me, have that little vent for a moment.
Okay, one more question. Okay, how about a book named Brave SUI World?
Catchy.
I just wanted to give them that idea. Okay, we would like to give you some things to show our appreciation, starting with your registration material.
Oh, thank you very much. I appreciate it. This is a great story that I have of being locked in my hotel because they were demolishing the building next to me. So,
yeah, we're really lucky you made it over here sort of just in time to be just a little fashionably late.
Right.
And we would like to give you this plaque and appreciation of your yeah.
Thank you very much.
Yeah, thank you for coming out.
I'll just leave that there and clear the stage.
Yeah. So